A unit vector is a vector with a magnitude of 1, and to our biggest surprise, a unit vector has no units. So, what's the purpose of unit vector? It is used to point the direction in space, and it can be used to represent any vector, be it force, displacement, velocity, acceleration, and so on. So, if you have a vector towards the x direction and it has the magnitude of 1, that is a unit vector. You can have another one in the y direction, magnitude of 1, in the z direction, magnitude of 1. That is a unit vector. So, let's say you have a vector A from here to here. This is AX, which is the x component, and this is AY, which is the y component. Remember, AY and AX are scalar. But in the case of unit vector are represented with I with a caret sign, J with a caret sign, and K with a caret sign. I pointing towards positive x-axis, J pointing towards positive y-axis, and K pointing towards positive z-axis. So, if you say AXI, that is a vector quantity, because AX, which is the component, is a scalar, but the moment you had this, you already point towards the direction, so that makes it a vector quantity. Now, what if you have another vector, let's say from here to here, and trace it down? You have your BX, and here you have BY. We can add these two vectors together. Let's say the summation of the two vectors give us R, which is the resultant from here to here. We could say R is equal to A plus B. R vector is equal to A plus B. And we already know A is equal to AXI plus AYJ, and B as well is equal to BXI plus BYJ. So, if R is equal to A plus B, we could say R is equal to AXI plus AYJ plus BXI plus BYJ. This is straightforward. Now let's collect like terms. This have I, this one also have I, this one have J, and this one also have J. So the ones with I, bring them together, the ones with J, bring them together. So AXI plus BXI plus AYJ plus BYJ. Now, we could bring the I out of a bracket since it's common here and here. So we can say AX plus BXI plus AY plus BYJ. Easy. So, if you look at this diagram, we find out that AX plus BX would give us Rx, since R is our resultant and this is the S component of R. So, something like this, Rx, and here we have Ry. So, let's come back to the equation. rx I plus ryj. So vector r is equal to this. Now this is a complete vector, unlike just when you have the components. This is a component and a pointer, which is the unit vector. Now we could find the magnitude of r by saying the magnitude of r is square root of the x component square plus the y component square. But there are some vectors that couldn't be represented with just x and y axis. We need another axis like z axis. For example, on many occasions we've heard of players who could score a goal from the corner. Let's say here's the corner and here's the player and here's the ball. Now if you look at this motion very well, one thing is sure, there are many players here, and as a wise player you would not want to play the ball at the ground level because it is easy for this player to just kick it out. So you want the ball to go above their heads. So the ball must move upward in the y direction. The ball must leave this place and go towards the goal post. So the ball must move in the z direction, and the ball must as well go this direction so that it can enter into the goal post. So it must move in the x direction, though this is the negative x direction, but the ball is moving in 3 directions. So we need something that could represent 3 directions. So if we want to represent this whole thing with a vector, we could say if this is a, the vector a is equal to axi plus ayj plus azk. Now, what if there's an header here and the player decides to kick the ball to target the head of the header, and the header also head the ball back to the net? This is 2 different things happening. The ball from here to the head of the header and from the head of the header to the goalpost. 2 things. If this motion is called A and this is called B, that means from this point to the goalpost is A plus B. Let's call it R. We could say A is equal to AX I plus AYJ plus AZK, and B is equal to BXI plus BYJ plus BZK, and R is equal to AX plus BXI plus AY plus BYJ plus AZ plus BZK. And obviously AX plus BX will give us RX. We have something like that earlier before. So we can say RXI plus RYJ plus RZK. So to find the magnitude of this, remember magnitude is a scalar. So magnitude of this, which could be written as R, is equal to the square root of Rx square, which is the x component, Ry square, which is the y component, and Rz square, which is the z component. It's as easy as that. Now let's give it the figure. Let's say ax, ay, az, bx, by, bz. Let's say this is 1, this is 2, this is 3, this is 6, this is 5, this is 3. We could say a is equal to 1i, which is same as I, plus 2j plus 3k, and b is equal to 6i plus 5j plus 3k. Then r would be equal to 1 plus 6, 7i plus 7j plus 6k. That's it. So practice those questions, they would help you a lot. Thanks for watching.